Okay, so it's 522. This is video number 100. Boy, we've reached that number, huh? How about that? And this is about using bigger numbers for the assignments that I gave you. It's sort of like an enrichment class, but you can look at it any way you want. So I want to do these for you, and then you let me know. Probably I'll give you an assignment with a couple bigger numbers on it as well. Just a couple cases here where we're using the FOIL method to, by the way, a little bit of scientific notation. You'll see I did that as well to do these problems. So anyway, on this first problem here, I guess we can put a 1 here and a 2 here, whatever. We see that we need to calculate, using our brains, 2003 squared. Okay, so let's see what we did. We broke it up into the format a plus b squared, and a equals 2000, b equals 3. This has been explained to you. I'm sure you're communicating with me if this doesn't make any mistake. And then let's follow what I did over here. So it's 2000 plus 3 plus 2000 plus 3. And because there are 1, 2, 3, 1, 2, 3, I took 2 times 10 to the third and I squared it. Okay? So there we go. That's an application of work that we did in 8th grade. Let me move this over a little bit over here. Okay? And of course, 3 times 3 is 9. And then 2,000 times 3 is 6,000. And you double that and you get 12,000. And so I just added up the old-fashioned way. It's the easiest way. Notice the check over here where I started counting the 6. Okay? Because after all, you get 2 squared times 10 to the 6, which equals 4 times 10 to the 6th. I love to do the work that we did previously. Tie everything in there. And I added everything up, and look at that. Here's another perfect square coming out of the woods. 4,012,009. I wonder if 12,009 is a perfect square. I doubt it. Anyway, so that's the way we did that one, and so I'll probably give you an assignment to ask you to do a couple of those, really exotic. But notice you didn't need a calculator. Again, there's this guy, there's that guy, and there's that guy to come up with the total without a calculator, without the need of one. And of course, if you put the hat over this, you'd end up getting 2003. Okay, and on number 2, I'm multiplying 2 numbers together, but they're not equidistant from another number. One is 4 away and one is 5 away. But I wanted to show you that you can still do this math, no problem. I turned 46 into 50 minus 4, and 56 into 50 plus 6. Should be easy for you guys to figure out what I did. But now, the middle term doesn't go away. Does everybody see that? We're focused here on that. Okay? The middle term stays. Okay? So here's F, as I go left to right. Here's the L. Here's the O, and here's the I. And when I put these numbers together, 25 plus 300, there's the 2800, and negative 24 and negative 200, and put them together, we get the correct answer, which is right over here, which is 2576. So yet again, I should give you one of those as well. There it is all written out. Okay, so you can see what I did. Okay, I put the, it's FLOI, but it doesn't really matter. The ideas are still the same. Okay, so let me do a third problem here as we're finishing up this subject, or at least the explanation of it, because we're going to move back and we'll be back to this. Again, this is just standard Regent stuff that all kids your age do at some point in time or other. Hopefully the sooner the better, because most of you would be much better off taking the Regents as soon as possible. So there we go. Okay, and now I'm going to focus on another problem that I did, again with big numbers just to show you. So the question would be, in this particular case, what's 3004 times 2,996? So this time I made them equidistant from 3,000 so that I could get rid of the middle term. And since I have it lined up nice here, I'll just go from top to bottom. So then this becomes 3,000 plus 4 times 3,000 minus 4. And then again, I use my skills from scientific notation. So that's 3 times 10 to the 3 squared minus 16. And there's your answer right away. Why is that the answer? Because again, since these are conjugates and all the numbers are the same, the middle terms cancel. So that was an easy calculation. Of course, this is squared. Sorry about that. Okay, that is 3,000 times 3,000. So we end up with 3 times 10 to the 6th minus 16. And that's going to equal 8,999,984. And so did the honors for you there. So there we go. Using bigger numbers, we're able to easily work these things out without a calculator. And I like the little idea that we put in there, the little rub there, where we use scientific notation to get our work done. So there we go. Again, you can check all this stuff on your calculator if you choose. Using bigger numbers and using the FOIL procedure with bigger numbers, we've managed to do math using the FOIL technique and using those 3, and I'll put them over here one more time, those ideas that we used at a plus b squared, a minus b squared, and not to be confused ever, a squared minus b squared. And by the way, I got the question the other day, is b squared minus a squared any different? And the answer is no. It just depends what you call b or a, because this is just going to turn out to be b plus a times b minus a. So it would depend on what the restrictions are here. It works either way, depending on what you're willing to call each A and each B. So I mentioned that in passing here. So there's 1, there's 2, there's 3, and now we're going to be moving on to factoring monomials, and we'll come back to this when we get to factoring of binomials, okay? So there we go. I'll put this in an assignment on Tuesday and move this around just a little so you see what I did. Okay, there's a synopsis of everything we did over here, and there's the last problem that I did. So I'll give you some problems like that to do next week, and we'll consider the topic taught. Okay.